I'm the calculus professor, and today I'll be talking to you about properties of power series. In problem number 21, we'd like to find the radius of convergence and the interval of convergence for the following power series. We want to look at the sum of k squared x to the 2k divided by k factorial. And what we want to do here is we want to use the ratio test to help us figure out for what values of x does this thing converge, what values of x does this thing diverge. So we're going to use the ratio test. So let's start with a limit as k goes to infinity of absolute value, and that's very important to put in the absolute value, of this guy, except put in k plus 1s instead of all the k's. So instead of k squared, I have k plus 1 squared. I have x to the 2k, so that will be x to the 2 times k plus 1 divided by k factorial over here. So over here I'll have a k plus 1 factorial divided by, and then I put in this guy with k's instead of k plus 1s this time. So k squared times x to the 2k divided by k factorial. All right, so this is how we start. Now let's flip this fraction and multiply and see what we can cancel out. So let's rewrite. So this is the limit as k goes to infinity of k plus 1 squared times x. It's to the 2 times k plus 1, but if I multiply that out, that's x to the 2k plus 2. So this is to the 2k plus 2 over k plus 1 factorial times, if I flip and multiply this guy, I get a k factorial on the top, and on the bottom I have k squared and x to the 2k. All right, so now the question is, what cancels here? How can I simplify this down? Let's not forget our absolute values. Okay, how can I simplify this? Well, I have x to the 2k on the bottom, and I have x to the 2k plus 2 on the top. So I have 2 more x's on top than I do on the bottom. So I can cancel all of these with almost all of these. I'll just be left with an x squared. Also, I have a k factorial on the top. I have a k plus 1 factorial on the bottom. I can cancel k factorial with all but the k plus 1 on bottom. So k plus 1 factorial is k plus 1 times k factorial. So I canceled out all but the k plus 1. Okay, anything else I can do? Yeah, I see one more thing. I have a k plus 1 on the bottom. I have a k plus 1 squared on the top. So this k plus 1 cancels with one of the k plus 1s on top, and I just have k plus 1. Okay, let's rewrite now and see what's left. I have a limit as k goes to infinity of, on top I have a k plus 1, and I also have an x squared. On bottom I have a k squared. So what happens to this guy as k goes to infinity? Well, the power of k on the bottom is bigger than the power of k on the top. And we know that if I'm taking the limit where k goes to infinity and the power of k on the bottom is bigger, then that limit goes to 0. By the way, I forgot my absolute values again. We need to make sure to keep writing those in. So this is equal to 0. Now, 0 is less than 1. And this limit is 0 no matter what value I use for x. So whatever I use for x, I get a 0 out of the ratio test, which means no matter what value of x I have, this series over here will converge. So this thing converges on the interval minus infinity all the way to infinity. In other words, it converges everywhere because any value of x that I use gives me a ratio test that says it converges. So this thing converges on the interval negative infinity to infinity, and in that case we say that our radius of convergence is just infinity. So my radius of convergence is infinity, my interval of convergence is minus infinity to infinity. So no matter what value of x I plug in to this series, I get a convergent power series.